Really, this process is subdivided into essentially two stages. The first stage is electron transport, and that means you are passing electrons from one molecule to an acceptor molecule and then moving it along until you eventually give it to oxygen. Okay? So all of that is occurring. Here's the inner mitochondrial membrane there. All of this is the membrane, and you have various components in that membrane. Second important thing that happens, every time you move electrons, let's say from NADH, along from, say, left to right, you release, that plus is a proton. And that proton is released in the intermembranous space between the inner membrane and the outer membrane would be up here. It's not shown. So that means that proton gets trapped there, mainly because of the inner membrane, mitochondrial membrane structure that is highly impermeable. So this is basically what will happen, is that you oxidize NADH at, say, the first complex. We'll get to the details in a minute. You move, when you oxidize something, that means it's lost the electrons. The electrons are moved to an acceptor. So there's always going to be something losing electrons, something gaining. There's no electrons disappearing. Okay? You have to account for them. So you lose them from NADH, something else gains them. And eventually they get moved along until they are passed to oxygen. And again, I'm going to tell you, this is where the oxygen we breathe is used. This is 95% of the oxygen we breathe in this process, believe it or not. Okay? But every time you move the electrons, let's say from left to right, you're going to produce these protons that get trapped in the intermembranous space. Eventually, these protons here accumulate, and you get what is called an electrochemical gradient, meaning there's much more protons in the space than in the matrix.